Hello, welcome to lecture 7. Today I am going to talk about area and volume. This will be covered in two parts. This is the first part today. This is mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. Okay, today I am going to start with areas and volume, and to build up this idea about areas and volume I will start like this. This is one dimensional line. So one dimensional line means, suppose I say fourth block. So 1, 2, 3, 4. This is a fourth block. So only one coordinate is required. Okay. Or I say second block. 1, 2. This is a second block. I say fifth block. 1, 2, 3, 4, 5. This is a fifth block. So only one coordinate is required to represent one of the block. Okay. So this is 5 unit. I have put 5 blocks of. I call this block as unit. So there are 5 units have been placed. The unit can be anything: millimeter, centimeter, inch, foot. Okay. So if I have say 1 centimeter block, 1 centimeter, so this length of this line will be 5 centimeter. If it is 1 millimeter block, then the length of this line will be 5 millimeter. Okay. So this is line one dimension. This is like they are all laid in one line. But suppose I have one line and then again I put on top of it another layer. Now if you have to say which block, suppose this block you require 2 coordinates. I will say that first go to fourth block and then go one above. So this block will be represented. So this generally required 2 coordinate. Okay. One is in the x direction here and another one is in the y direction. So total unit in this 5 unit plus 5 unit, there are 10 units. So these are called 2-dimensional structure. You can make triangle, circle. These are all the area inside the triangle and circle. There are 2-dimensional areas. Now we define what is an area for rectangle. Similarly, if I have say 7 units, 7 blocks, and I put 3 layers or 3 lines, one on top of each other. So you have 7 here and 3. So 7 into 3, 21 units. So there are 21 blocks or 21 units. So area for rectangle is base into height. Okay, this is say the base and say this is the height. So you have to, whenever you say base, that this unit and this unit you convert into similar unit. Suppose one is given in centimeter and this is given in millimeter. Either you have to convert this into centimeter and centimeter, or you convert this centimeter to millimeter and this millimeter. So generally similar unit you have to. I hope you all know what centimeter, millimeter, inches, foot is by now in class 9. So area for square. Now you same, suppose you lay 5 bricks here like this, 5 unit or 5 blocks, and same number of layer you suppose you have put 5 and here 5. So this is a square. So there are altogether how many blocks? 5 blocks? 5. So 5 into 5, 25. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You count it, 25 it will. So area for square is base into height and of course unit square. Okay, this I am introducing because when you do physics, you will require all this. Unit has to be written properly. Just 25 doesn't mean anything. You have to say 25 what? Centimeter square, millimeter square, or foot square. You have to tell. Otherwise, then only this number has some meaning. So area for parallelogram is again base unit into height unit. That is, suppose I lay 5 brick here, then another layer, another layer, another layer. Then you see that the area will be, this is half here and this is half here. So 1, 2, 3, 4, 5. So each layer will have 5. So there are 4 layers. So base is 5 and layer is 4. So 5 into 4, 20. So 20 unit square. Okay. Area of a triangle, we can see that, okay, I place first 6 unit, then I place 5 unit, okay, then third layer I place 4, then 3, then 2 and 1, and I join these endpoints. So if I see this, how many squares are there? The first one will have half inside this line. You exclude this outside ones, outside the line. So if you include all this, and the number of unit what you will get is, here it is 1.5, 1.5, 2 box and half, 2.5. And similarly here it is 5.5, 1, 2, 3, 4, 5.5, 5.5. So totally if you do it, it is 18 unit. So you can write the formula as base is 6 unit, height is 6 unit, but you have 18 unit total. So 6 into 6 is 36 divided by 2. So half base into height unit square. This is a formula of a triangle. Okay. So this is very simple way of proving it, and we will go about proving many things with this kind of a block. Okay. Now we will talk about circle, and it is found that the circumference, this is the circumference of a circle, this is the diameter, a chord passing through the center is the diameter, and this is the radius from center to anywhere, any point on the circle is called the radius. So it is found that circumference C is proportional to diameter. So what I mean to say is that if diameter is big, circumference is big. So circumference is proportional to diameter. This symbol is proportionality. It is not equal to. So how do you make it equal to? By putting some proportionality constant pi. So then it becomes, okay. So this pi is a constant, is a proportionality constant, and circumference, this is d, d is twice r. So circumference can be written as twice pi r or pi into d. Okay, because d is 2r, no? So I have written here 2r. So how do you really find the value of pi? Okay, this is a very primitive way of finding pi, but there are more sophisticated way which we will deal in the higher classes. So this is a circumference. Okay, so you can cut this circumference and measure the length perimeter, okay, of this circumference for a particular diameter. So for a very small diameter, you cut the circle and measure the circumference. Then slightly bigger diameter, you cut the circle and measure the circumference. You go on doing it, you will see that it will fall on the straight line. Okay, so you say that the circle is proportional to this, linear, and this slope, this is your slope, that is y by x. I will define what slope is. Okay, this slope is nothing but pi. Similarly, what you can do is you measure the area of the circle. I will show you how to measure the area of a circle. Suppose you measure it by these blocks, but I will show you some other method of measuring the area too. So suppose you measure the area, make small blocks and measure the area, and you keep on increasing the diameter and use the similar size blocks, and you plot here that area of a circle with r square. Okay, this is your r square. You know what radius is because you have drawn this circle yourself, so you know what radius is. So if you plot area versus r square, again you will get a proportionality constant which is pi. Okay, so area is equal to pi r square because it is proportional to r square and the proportionality constant is pi. Okay, this value of pi here obtained from here or value of pi obtained from here will be same. It's typically, roughly speaking, it is 3.14 or you write 22/7, but we'll come to all these things in a higher class. So as I said, what is slope? Slope is, suppose this point, that is dy by dx actually slope is. That means change in the y with respect to x. Okay, that is a slope. So here change in y is what? Y was here 0 to y and x was 0 to value x. So this point is x, that means you move towards x, that much amount of x, and then move on the y direction, and this is a y. Okay, this is y axis and this is x axis. So you write in a coordinate form x comma y. Okay, if it's a single line, only one line is enough. So one coordinate is enough. Now since it is a two-dimensional, you have to represent by two coordinate. And slope is y minus 0 because this is 0 here. This much it has moved. And x has moved this much. So x minus 0. Okay. So this is a slope. The change in y divided by change in x. So y by x is equal to pi. Okay. So similarly here slope also is y by x. So y by x is y is what? In x axis a by r square, that is pi. Or c is equal to pi into d, 2 pi r. But intuitively, how do you prove that area of a circle is pi r square? Here we have shown. taking a very similar idea what we have shown above. What I do is I take a circle, divide into many equal parts, and I place, this is say part 1, part 2 and so on. I place this part 1 here, part 2 here, and then what I will get, this length here, this is 1, 3, 5 and 2, 4, 6. So this is half actually, okay, half of the circumference. So I have written half of 2 pi r. But here you see this is a slant which is a radius. To make it straight like this r, I cut into many pieces here which I have shown, into many pieces, and then I will get this extra curve will also become small. Then I will get, I can approximate this as half of 2 pi r, this length, and this height as r. So I have a here parallelogram A, B, C and D, and area of a parallelogram is base into height, which we have shown earlier. So if I put here base is half of 2 pi r into height is r, so 2 get cancelled, so you have pi r square. This is another way of getting yourself convinced, okay. And another second way is like this, you draw a lot of concentric circles. If you have this circle, you draw very small with small radius and keep on increasing, and you say this is like thread, okay. You cut this, all of them along this, and you place it here, small thread for the small circle, and the largest will be the circumference of the circle. So that is 2 pi r, which we know, we have shown here. And this, if you keep on placing it, this thickness will be r, okay, this thickness will be r, okay. And so area of this triangle is half, base is r and height is 2 pi r, so it is pi r square, okay. But when we go to integrals and higher class, we will derive this area of a circle and all in a much easier way. But this is just to pictorially that, okay, this you should remember. Now area of a trapezoid, this is trapezoid, this is a trapezoid, A, B, C and D, this is a trapezoid, okay. That two lines are parallel, but opposite two lines are parallel, but not, only one pair is parallel, but not the other one, okay. And they can be of different size, okay, or can be equal, then they are isosceles trapezoidal, okay. So anyway, we take a general one, and what do we do? I take this and reflect it here. So now I have two trapezoid. Then I move this one here. So I have now a parallelogram, you see. But this is twice the area of the trapezoid. So if I know the area of a parallelogram, half of it will be the area of this shaded trapezoid, okay. So area of a parallelogram is B1 plus B2, B1 plus B2, and this is the height, say h. So area of a trapezoid is half times of this parallelogram, that is parallelogram area is h times V1 plus B2, so half time of this. So area of a trapezoidal is this, okay. Here I have shown some picture, just freeze your screen and see what I have explained, that I can move it here, I can get a parallelogram. So it is a base into height is a area of a parallelogram. But trapezoid, here I have taken two trapezoids, so I have to divide by 2. So I have divided by, this is the area of a trapezoid. Area of a rhombus is also, this is a rhombus, okay, and they are all equal length, all the sides are of equal length. So what I can do is I can move this here, I can flip and move it here, I can flip this and move it here, I can cut it here, this shaded region, move it here. So now suppose this is the width of this line, the length of this diagonal is say D2, okay, this is D2. So I have taken here half of it, will be half of D2, and here it will be, suppose this is your D1, so here I have taken half of D1. So there are two rectangles, okay. So this is the area of this is half of D2 by half of D1, then again similarly here also half of D2. So here I have written here, so it is 1/4 for area of a rectangle at 1, and area of rectangle 2 is d1 1/4 of, okay, half into half is 1/4, okay, or simply you can take as this as d1, so half of d2 times d1 is half of d1 into d2, okay. Area of a kite you can similarly prove. Here again you take this one and put it here, and this one and flip it and put it here. So you have half of d2 times d1, means base into height. So you have this. So here I have tabulated quadrilaterals and area formula. So you have square, area formula is a square. Here both the side, all the sides are same, a equal to b. Rectangle, here a is not equal to b, okay, and a I consider as a height. So area of a rectangle will be base into height, that is a into b. Similarly, parallelogram we have proof, it is nothing but parallelogram area is base into height. It is base into height, but not this a. You have to know this height, okay. For trapezoid, it is, we have shown that it is half of a plus b times height, we have shown. For rhombus, we have shown that also, or you can divide into two triangles. Here I have shown, just freeze and see it, okay. And this triangle, if you add, this is one triangle, 1/4 d1 into d2 plus 1/4. So I am trying to say that there are various ways of proving this geometry, so it has to be logical. That's why I have shown here one more way of showing it. Divide into triangle and do it. That is also allowed. So area for kite, this also can be, I have shown another way by which you can prove, that is breaking this into two triangles, this one triangle and this big triangle, and you can add the area. So area of this triangle, a triangle 1, say this is, and this is triangle 2. Area of triangle 1 is half of base is d2 times, say it is some fraction of d1, a times d1, I can write. And area of triangle to second triangle is half of base, which is d2, and some fraction of d1, that is b times d1, where this fraction, if you add a and b, that should be 1. A plus b should be 1. Then a plus b, when is 1, if you add these two, it will become d1. So here I have added 1 plus 2. I have added both the triangle 1 and triangle 2, half. This d2 is common. You have a times d1 plus b times d1, but a plus b, as I said, is 1. So half of d1 times d2. So this is the area of the kite. It's similar to area of the rhombus, okay. So you can also obtain the area of a circle from area of a regular polygon. That is, you have a circle and you have drawn a polygon, but here you see it has not covered the full circle. So you make these polygons many sides, smaller, this chord you make it smaller and smaller, so almost it will fall on the circle. So then I can write area of a polygon is, okay, this is all, each are triangle, I can approximate as triangle, that is half time base is your s, times the height, here a, okay, height is this one, not the r, okay, this is the height. But if you make it smaller and smaller, this s, this height will come close to r, okay. So here I have written this n times s is nothing but the perimeter, times a is this, perimeter is the circumference, okay. Perimeter is n times s, r is the radius, a is the height of the triangle, okay. So if you make it a much smaller chord, okay, many triangles, then your r will be almost height of a triangle. So as n tending to infinity, okay, p is nothing but 2 pi r, that is your circumference. So p is 2 pi r, and a will tend to r, okay. What do I mean n tend to infinity? Means many sides, okay, not only 6 sides here but many, okay. You make smaller and smaller this s, this chord. So area of a polygon now will tend, as n tending to infinity, will become area of a circle. And what is the area of this polygon is half, here I have written half time p times a, So P is nothing but perimeter or circumference is 2 pi r. I cancel this 2, I get pi r square. So here also, from here also geometrically, from using idea of polygon, I can get the area of a circle. Okay. So we proved area of a circle in 3 different ways. Now volume, as I mentioned earlier, volume is a 3-dimensional object. Okay. Generally line, then you have an area which is a 2-dimensional surface, and volume is a 3-dimensional. So what is the 3 dimension? This is the width, this is the depth, and this is the height. Suppose I lay 5 bricks in width, and deep is say 3 bricks, and then I make a height 2 layer. So volume will be your width times depth times height. Okay, so volume is width times depth. Suppose 5 unit, this is 3 unit, and this is 2 units. So 5 unit into 3 unit into 2, this is 30 unit cube. 3 times unit is multiplied. Each comes with a unit. 5 alone doesn't mean anything. You have to say 5 centimeter, 3 centimeter. If suppose it is 2 millimeter, then you convert into centimeter. Okay, that I am sure you all know. 10 millimeter is 1 centimeter. So that's way you convert. Suppose 1 millimeter will be 1 divided by 10, that is 0.1 centimeter. Okay, that I'm sure you can go in your previous textbooks and find it. So volume is W, that is a width or wide, depth into height, but this width into this depth will be the area of the base. Okay, or I call it this as a length, width and height. Okay, so this object is called a parallelepiped. It has some volume. It has the faces are quadrilateral. Okay, this is one. This has 6 faces: 1, 2, 3, 4, and then top and bottom. So the volume is nothing but, if I call this as length here, this is width. So length into width will be the base area times height. So I can also write a volume of a parallelepiped as area of the base into height. Okay. Similarly, of a cylinder is circular base area of a cylinder, which is pi r square into height. Like here I have said base into height is a volume. Here also base into height is a volume. So volume of a cube, all edges are same measure, that is length, width and height. Say it is S. So it is S cube. So now volume of a pyramid. So now suppose I take a center of this cube and I draw the diagonal. Okay. So I will get this as square base pyramid. So what is this will be, how many such pyramid I can have? I have 6 faces. So each face will have one square base and which will end at this center. So I will have 6 such square base pyramid. So the volume of this one pyramid will be 1/6 the volume of the cube. So now what I have done is, this is the height, this is the center here, this is half of this height of the cube, this h is half of capital H, this is a capital H. So if I substitute this h, which is equal to 2 times small h here, so 1/6, this is the volume of the pyramid, 1/6 the volume of the cube, L into W into H, this is the volume of the cube. And if I substitute this capital H with 2 times small h, I will get 1/3 length into width into height. So length and width, this is the base. So 1/3 base into height will be the volume of this square base pyramid. Now we will try to find out volume of a cone. Okay, what a cone is. Suppose this figure embedded inside this cylinder is a cone. So when I say volume, that means not a hollow cone but a solid cone. So how do we go about finding it? Okay, so suppose if I make this cone has this radius and this height h, and this is the base. So volume of a cylinder is, we have seen it is pi r square times h, and cone is inside this. So I project it in 2D. What my aim is that I will make this cylinder thinner and thinner, and also this R I will reduce accordingly, and I will make this kind of a pyramid with cylinders. So if I make very thin, this excess volume which is here, you see, if you make many cylinders, it will reduce this excess, this will reduce, so this will reduce. So you can imagine that if I make many thin slices and keep it, so it will approximately look like a cone, and then I add all the volumes of all the cylinders, and I know what is the volume of a cylinder is very easy, which we have seen, that pi r squared times h. So then my job becomes easy if I can add all the cylinders. So here it is depicted in a 2D projection. This only one side of the cone. Okay. So if this is r, I can break in between and make h by 2, and this will automatically become r by 2 because this is your similar triangle. They will, as I have said earlier, this total distance is h. It has become half. So this is r. So this will also become half. Okay, same ratios. Now if I break into 1/3, so all this will h by 3. This is also h by 3. So this will also become in the same ratio. This will be r by 3, this will be 2r by 3, this will be 3r by 3, that is r. Okay. Similarly, if I break into 4 pieces, this is small one will be r by 4, then it will be 2r by 4, then it will be 3r by 4, 4r by 4, which is r. Similarly, I have put here these cylinders with h by 2 and r by 2, this is all h by 2. Or I put 3 cylinders, h by 3, this radius is r, so this radius will be 2r by 3, this will be r by 3, the top cylinder. Now I break further, instead of 3 cylinders, I take 4 cylinders, so I have similarly here r by 4, this will be r by 4, 2r by 4, the second cylinder, 3r by 4, the third, and then 4r by 4 is r. Okay. So similarly, if I keep on putting thinner slices of cylinders, and accordingly if I reduce the radius of the cylinders, and the smallest cylinders will be on top and the biggest cylinder will be on the bottom, then it will look like a cone, and if I add all the volume, as I said, of all the cylinders, I will get the volume of the cone. So here see example, I am saying the volume V1 is of the cylinder is pi r square h, volume of the cylinder. But this is not, this cylinder is not cone. So I break into 2. Okay, I am going towards the cone. So this volume, the second one, V2, of these 2 cylinders is nothing but the smaller cylinder is pi r by 2 square and height is h by 2. And the bigger cylinder is pi times r square, this is r. That is pi r square is the base times h by 2. Okay. So this is the base of the smaller cylinder times h by 2. So similarly, I can write like this. I can take common pi r square h by 2 as common. I can write 1, this 2 square I can write here. Okay. And 2 anyway I have taken out, so it is 1. So here I write the same thing. I divide and multiply here by 2 square and 2 square. This 2 square into 1 is 2 square, and now 2 into 2 square will be 2 cube. So similarly, volume V3 for this one, there are 3 cylinders. You start with small with r by 3. So base is pi times r by 3 square, the whole square, into h by 3. So here I have written here pi times r by 3 the whole square, h by 3. Similarly, the second from the top, second cylinder will be 2r by 3, and the bigger one will be this. So again I can do some, just freeze it and copy it down. Okay, this is the common. This is 3 square here. Okay, 3 square here. Then 2 by 3 square here, 2 square by 3 square, and this is 1. So this is a common term. So again you will get, as this is a common term, you can again, this becomes 3 cube, 1 plus 2 square plus 3 square. So when you have 3 volumes of cylinders, so this one, you write this common and 1 plus 2 square. So see this, here it is becoming 3. When you had 2 cylinder, it was 2. Okay. When there was 1 cylinder, Okay, this is pi r square h by 1 cube. So 1 cube is 1 only, then 2 cube, then 3 cube. For fourth, it will be similarly pi r square h by 4 cube, and 1 plus 2 square plus 3 square plus 4 square. One more term will get added. So similarly for n, if you have n cylinders, thinner and thinner slices, if you keep on adding, then you will have this pi r square h by n cube plus 1 plus 2 square plus 3 square plus 4 square up to n square. So this is if you consider many cylinders. It should be clear to you now. You just go through it. Here only I have taken 4, but if I take n number of cylinders, then it will almost look like a cone. That's what I'm trying to say. And this is the formula for the cone. So let us simplify this, because here this number, we do not know what this number is. So how do you know the number? Of course, this is a series. So for a given n, this series, which I call it, label it as 2, that means 1 square, 2 square, 3 square, square. This is the one. So series with square series. For a given n, this series will be written as n cube by 3, n square by 2 plus n by 6. So this is the formula for this series. N can be anything. Suppose you have n equal to 10, I put here 10, and I will get sum of all this up to 10. Suppose n is 100, I put here 100. So this is what it means. Okay, this is a formula for a given series. So Vn is equal to pi r square times h divided by n cube, and this is this series. Now make this also n cube and bring n cube outside. So to make this n cube, you have to divide by n here, and to make this n cube, you have to divide by n square. So this is what I have written. So for n very large, 1 by any large number will be very small. So as n tending to infinity, this will become 0, and this also will become 0. So the volume of the cone is 1 by 3 pi r square into h. What is this pi r square into h? Pi r square into h is the volume of a cylinder. So volume of a cone is 1/3 the volume of a cylinder. Okay. And here I would like to mention that we saw earlier also for the volume of a pyramid, it is also 1/3 base into height. So this is also similarly, volume of a pyramid and volume of a cone is like 1/3 base into height. So now let us prove this summation, okay, which is equal to this. For given any n, then this s square is this is the formula. So how do you derive this formula? Is very simple. This is, I am calling useful diagram. It is not given in your textbook, but since we used it to derive cone, so this is a sum. I call it this 0, label it as 0. That is 1 to the power 0 plus 2 to the power 0 plus 3 to the power 0. So any number to the power 0 is 1, we know. So if I add n numbers, then I will have 1 plus 1 plus 1 n times. So that is equal to n. So if n is equal to 10, you will have 1 plus 1 plus 1 plus 1 10 times. So if you add them, it will be 10. Similarly, suppose you have 1 plus 2 plus 3 plus so on, 4 plus 5 up to n. So any number to the power 1 is the same number, I know it. So that's why I'm writing here 1. So this is 1 plus 2 plus 3. What is this? This summation is nothing but I can write in an inverted form also, that I reverse this. This summation, this series is equal to this. Both are same actually, just only I have inverted it. So I take this series in inverted one and I put this series. So I have two same series, but one is inverted, one is not inverted. So I have 2s and I add now n plus 1. Here n minus 1 plus 2 will be again n plus 1. N minus 2 plus 3 will be again n plus 1. So how many n plus 1? N times it will be. So this is equal to n into n plus 1. So since it is 2s, I bring 2 here. So s is equal to n into n plus 1 by 2. So similarly, let us try to find out what is the summation of 1 square plus 2 square plus 3 square plus 4 square and so on up to n square. Okay, this is 1 plus 4 plus 9 plus 16, 4 square is 16 and so on. So this is what we have used it in our earlier proof for deriving formula of a volume of a cone. So we'll use a trick. You see how I'm slowly coming to numbers and slowly also using some geometry also. So to get the formula for this series, we'll use a trick using number triangle. What is number triangle? This is a triangle, and I write here 1, then 2, 2, then 3 of 3s, then 4 of 4s, n minus 1 of n minus 1, and n of n's. Okay. Now I rotate it here. I do the same thing, 2, 2, 3, 3. So this is another triangle. Okay. And n here. This is rotated. This comes here, this goes here. Then I rotate further here, and same thing I do here, 2, 2, 3 of 3s and 4 of 4s. Similarly, n of n's. Okay, here. Now I add them in the thing. So what I get here, 1 plus n, that is 2n plus 1. Then 2 plus n minus 1, that is n plus 1. This 2, n minus 1 plus 2 is plus 1. So this is n plus 1, and here one more n I add, so I get n plus 2n plus 1. So similarly I get 2n plus 1. Similarly here also I will get here 2 plus n and plus n minus 1. Okay. Again I will get 2n plus 1, because this minus 1 will get subtracted from this 2. But there are 2 n's, this 1 n here, another n here. So 2n plus 1. So on, if I go doing it, just go through it. Even the nth, this last row will also become 2n plus 1. Here is n, this is 1, n. So 2n plus 1. Okay. So now this triangle is this is the notation for summation, sigma, capital sigma. That means I write as, this is a symbol of writing this thing. Okay, 1 plus 2 plus 3 square plus 4 square, I write it I square, where I goes from 1 to n. Okay, here I have written small n, here I have written capital. So you can write small n. So there are how many of them? 3 of them. 1, 2, 3. So I write 3 of this summation, capital sigma, I equal to 1 to n, I square. This is equal to this triangle plus this triangle, three summations. So this is the one result. So how many I have now here? Here I have 2n plus 1, I take common. So first one is 1, then you have 2 of them, then you have 3 of them, and you have n of them. Okay, so this is what I have written here. So this one I write it here, that is equal to this one, 2n plus 1. And I know that 1 plus 2 plus 3 plus n is what? N into n plus 1 by 2, which we have proved it here. 1 plus 2 plus 3 plus n. Okay. So now I just simplify. So I square is equal to this summation of I square will be 3, you take it here, so it is 6. So you just simplify it, freeze it, and do this step yourself. Okay. Go through this, and it is a very simple step. Just expand this. Okay, here I have expanded this to n square plus n, I have written here, into 2n, then again n square into 2n to n cube. And then n square, this is n square times 1 is n square, then n times 2n is 2n square plus n. So similarly, this is 6, so 2n cube by this, n square. How many n square? 3n square. So 3n square by 6 is half, plus n by 6. Okay, so this is the formula which we have used to derive the cone. Okay, here we had used it. This is the formula for this summation. This is the formula. This is the formula which we have derived now. So thus we have learned that volume of a square base pyramid is 1/3 the volume of the cube, which we have seen. Okay, base into height is the volume of the cube. So 1/3 times base into height, and similarly here also volume of the cone is 1/3 the volume of a cylinder. And volume of a sphere also you can find in a similar fashion. Okay, and briefly I'll mention how, what is the philosophy. That you take a sphere and make this square base cone, and the square base cone, I know what is it. It is 1/3 base and since I have made it so small, this radius will be the height. So volume of each pyramid will be 1/3 this small b, area of one small this, but there will be how many of them, up to n. You distribute throughout the sphere. Okay, 1/3 r. Say n such block you have taken it, so bn. So you will have this is the base. So if all over this will be this area of a sphere. Okay, this if you add all the bases, you will cover the area, whole area of the sphere. So area of a sphere is 4 pi r square. We will prove this. Okay, area of a sphere also we will prove it. We will not take anything for granted. We will prove whatever we are going to say. So this is 1/3 r times 4 pi r square. So volume of a sphere is 4/3 pi r. And the area of the sphere we will prove it in page 46 of my note. Then surface area of a cone. So this is, suppose this is a cone. You know, in birthday and all you make cap, no? This cone is a hollow cone. Now if you cut it and unfold it, this is the cone here, if you cut it. But this is some portion of this circle. So when I say fraction, what it means? 2 pi r portion is considered out of 2 pi r. So 2 pi r divided by 2 pi. This is a fraction. So so area of a sector AOB is the area of the cone, because this I have cut it open and put it here. So this area and this area is same. So this is area is pi times r into L. Okay, now surface area of a frustum of a cone. What is frustum of a cone? If you have a cone and you chop the top portion, the remaining portion is called the frustum. So now we will derive what is the surface area of this frustum. Okay, surface area is pi times S. S is this slanting length times r plus r. So how do I derive this? I just take this projection of this cone as a triangle, and I say that triangle BPQ is similar triangle to BMC, which we have seen earlier in our triangle geometry class, and their ratios will be this r divided by t plus s will be equal to r divided by t. It's same thing. Okay, so now I don't want this t, so I want to remove this t because I have chopped it off. So I have this, I do cross multiplication, RT is equal to RS plus RT and T equal to. So, but I know that this big cone minus the chopped off thing is equal to the frustum. So the big cone is, capital R is the radius, so pi r times T plus S minus this one, that is minus pi RT. So now I get this, pi here I have taken common. You do some little bit of algebra and I substitute t as r s by r. So this r minus r will get cancelled. So pi times s is a common times r. Okay, today we will end this part 1 here. Thank you and see you in the next lecture for the second part.